Okay, if we want to go ahead and animate that per call and give a little extra control over it, we're going to go ahead and create a helper called Boolean. Boolean just stores a yes or no value, on or off, and we're going to turn on auto key, and then we're going to go ahead and animate this value. At frame 10 we'll turn it on. At frame 11 we'll go ahead and turn them off. Get out there again to frame, say frame 40, and we'll turn them on, and we'll leave them on for 20 frames. Turn them off at about 60. And so you can see what that checkbox is doing there. This value at 10 is going to turn on for 1 frame, then he turns off. He's off until we get to 40, and then he turns off at 60. We'll turn off auto key. Then what we're going to do is you're going to use that Boolean's on value to control born, which is going to say every time I receive an on input, or as long as my on input is turned on, I'm going to create 10 particles per call, or per time step. So what happens is we come out here, nothing's being born. As soon as we hit 10, boom, he's going to born 10 particles, and then he stops because that value is only true once, and so he only gave birth to 10 particles at frame 10, and then he stopped. Frame 11, Boolean value is turned off. He's not creating anything. We get out to frame 40. He's turned on. He goes ahead and creates 10. 41, Boolean still on, all the way up until 60. So all the way from 40 to 60, each one of these frames is a call. So each call he's going to give birth to 10 particles. Let's talk just for a little bit about per call and the time steps. On the master dynamic, we have something called viewport render subsampling. This controls how finely time is divided and how close, or how many substeps TP is going to use. Like right now we're evaluating every frame, and if we wanted to evaluate twice per frame, we would do per half frame. So this is going to give us 2 TP evaluations per frame. Now watch what happens to our count once we hit 10. First he borns 10, and then by 11 it's going to be 20. That's because actually at 10 and then 10 and a half, he gave birth to another 10 particles, because that per call also depends on what our time sampling is like. So that's very important to remember. If you want to emulate ticks, all you have to do is say samples per second, and remember that there are 4,800 ticks per second. And you'll see quite a few more particles being born here. Okay, let's get back on per frame. And so we've covered count, how many total number of particles alive at any one time. Particles per second, just kind of a general rate. Oh, and you can see that our on value is still connected to the Boolean. We'll go ahead and turn that off to see. There we go. And then of course we have pistol shot, where it will born this number of particles. Set like with per call off, it's only going to give birth to that once. Per call, it will be every time I receive an on value, and if my on is not connected, I will do that every time sample. Okay, so that's born. Born's pretty good for just creating particles into existence. There's a special case for born that let's go ahead and take a look at. It's pretty fun, because we don't explicitly have a generator for giving birth to particles inside of a volume. And one of the ways that we can recreate that and save that into a black box in TP, let's go ahead and get rid of these things. We'll do an Alt right click to get rid of those two. And we'll just double click born to close him down, and then we'll expose his born particle output. Let's just do a quick review of these outputs. Born particle is going to send out, his particle ID value at his birth. So if you have a velocity assigned to him, you can think of this as velocity being assigned to that particle at birth. If you have another rule or another dynamic set further down here, where we're going to affect red particles, we can say red particles are going to have velocity. This rule is going to affect red particles every evaluation step. Remember, TP evaluates this tree top down, left to right. So when the particle's born, he's going to be given a certain velocity, but in the next rule, that velocity for the red particle is going to be overwritten. Really, the important thing to remember is that this born particle output is only being assigned when the particle is being born. If you use a regular p-pass operator here, for these groups, any of these here, these are assigned and updated, in this case, all the time, every time step. So just remember, born particle only at birth, regular particle group all the time, unless you're going to modify as on inputs or something. Okay, so enough of that. Let's go ahead and remove that second rule.